This is section 524, Inverses and Logarithms. We're going to look at the transformations of logarithms. So today we're going to examine how a logarithmic graph transforms. So fortunately, the concept of h, k, and a are the same. This is that graphing form for a log. A times log of x minus h plus k. Now, this is something you need to memorize, right? We need to know the h, we need to know the k, we need to know what a does. We need to know what the parent graph form is so that we could easily shift our graph. You just draw the shape and shift it. Remember that h is our horizontal shift, k is our vertical shift, and a is the vertical stretching and shrinking, which includes the reflection over the x when it's negative. So let's go ahead and look at Desmos to see what it does. Starting with log base 2, this was a graph introduced in yesterday's lesson. And if you notice, remember I said that this is the parent graph that we have to remember. It starts at 1, 0, and it has this type of shape. Now remember, we talked about the graphing form of the equation. It doesn't matter what the base is. So if you notice the base, I'm just using base 2. It's going to, even though we already talked about as the base changes, that's going to change the way that our graph is going to look, right? It looks like it's getting stretched more horizontally as that number gets larger. But the h, the k, and the a all do the same thing. So for example, if I have log base 2 of x plus 3, this right here is my horizontal shift. Since in the formula it's x minus h, a negative and positive is a negative, so it's going to shift over 3 spaces. So there, my starting point 1, 0, it's going to shift over 3 spaces to here. X minus 5, so my h is 5, so this is going to shift over 5 spaces. 1, 2, 3, 4, 5. So that value there is what shifts. I know we all get the 0, 0 in our head, but it's the 1, 0 that shifts. Log base 2 of x plus 4, so my k is 4, so this value is going to shift up 4 spaces. So that shifted up 4. It's going to shift down 2 spaces. So it's going to be right there. So that moved downward. Now the a, it's still vertical stretching and shrinking. So this is a vertical stretch factor of 3. And so it looks like the graph is going to get pulled vertically. And so it's going to, see. So this graph here gets pulled upward. This graph here got pulled downward. And then now this is a vertical compression. So you're going to see that it's going to get pushed down. This is going to get pushed up a little bit. So you got pushed down. That got pushed up. And then this negative still means a reflection. So this is going to, basically, it's going to reflect over the x-axis. And so this is going to end up going upward. This is going to end up going downward. So that ended up reflecting down. That reflected up. And so then we ended up with that as our new graph. So to close today's lesson, we talked about how we can transform a logarithmic function. So what does h do to a logarithmic function? H is the horizontal shift. It's going to take the graph from the starting point, which is 1, 0, and shift it left or right. What does k do? That is the vertical shift. It's going to shift the graph up and down. This does conclude our lesson. If you have any other questions, please leave them in the comments.